So, all right, we'll have to start. Okay, are you with me, Shakiruddin?
Yes,
Okay. Uh, so we'll continue from where we stopped in the last class. I would have loved these guys to be here so that they will not take us back because we've dealt somehow on projectiles, impulse and momentum, and forces, vertical motion, horizontal motions, relationship between mass and acceleration, distance and acceleration, equations of motions, and when to apply them and how to apply them. But we can't continue to wait for them. So I will just explain a few things now for you as we kick off. Now, talking about projectiles, a projectile is a, since you already, I believe you have touched it, even if not in details, a projectile is any object or a body that can travel in a type of a curved path or a parabolic path. Okay, that's how it is called normally in physics, a parabolic path. So examples of projectiles you have, we have done this and I'm just giving you a refresher so that you don't miss too much. Examples of projectile motion, you have a bullet fired from a gun, a stone released from a catapult, an athlete doing the high jump, the person will just run towards the pole and then jump across it to the other side. That is a projectile motion. Another example is a thrown rubber or a ball rebouncing from a wall. If you throw a ball against a wall, it will rebounce. So it's also an example of a projectile motion. Please don't forget those examples I've just given now because I've seen questions where they will list options and ask you to pick which one is an example of a projectile motion. Oh, I really hope these guys will join us on time because there are things I am saying now that if they if they come online, they might not understand what we are doing if they are not here. Please, I want you to take note of what I'm saying now. Listen very well. Now, another thing I want to say is in a projectile, when a projectile is projected, it has an initial velocity and it has an angle. It travels in a curved path, so it has an angle either to the horizontal or to the vertical. Please take note of that. A projectile has an initial velocity and an angle to the horizontal, for instance. So we can resolve the velocity of the projectile horizontally and vertically. We call it the initial horizontal component of the velocity because you can have a question like that. You can be given a question on projectile and you're asked to find the horizontal component of the velocity or the vertical component of the velocity. That's why I'm mentioning this. We don't have to leave that out. Okay, so uh, v- horizontal component of the velocity, that is y-axis. Don't worry, I will still share my screen with you. I'm just doing a form of introduction so that when we start calculation now, you understand what I'm doing. The horizontal component of the velocity is resolved by using a u cos theta. U is the initial velocity, theta is the angle at which the projectile is traveling. U cos theta is the horizontal component. Please, I want you to write it down. While U sin theta is the vertical component. U cos theta is the horizontal component. U sin theta is the vertical component. Don't forget that. Are you still with me?
yes, sir.
Okay. So I'm mentioning it so that we know when we apply it. Like when do we apply it? What kind of question do we apply it to solve? So we'll see all of that now. What did I say is the horizontal component of velocity?
You cos theta,
Okay. What are vertical components?
you sin theta.
Good. And you know that horizontal component is the y-axis. So which means if they're asking for velocity along the y-axis, horizontal, that is x-axis, like ground motion, motion on the ground. Then if they're asking you for the velocity along the y-axis, that is the vertical component of projectile. You can be asked. So it's not always find your range, find a time of flight or time to reach maximum height or maximum height itself. So they can just try to twist question a little. So keep that in mind. It's not hard anyway, but all you need to know is when do I apply these things? When do I apply them? That's why I'm just introducing them to you since you're just joining us today now. But don't mix them up. Don't mix sign for cos. Okay, it's possible to mistakenly think vertical component is u cos theta, horizontal component is u sin theta. It's very possible. You know, it's easy to make mistakes. So please let that stick with you very well.
Okay.
Good. Thank you for following me. Another thing I want to mention now before we start calculation is that the horizontal component of the velocity remains constant. It does not change. Don't forget that. The horizontal component of the velocity of a projectile remains constant. Why? Because no force is acting in the x direction. No force is acting in the x direction. But the vertical component changes because it is subject to gravity. Force of gravity is acting on the projectile vertically. You know, the object is going upward, kind of. So gravity will be pushing it. So force of gravity affects the vertical component, but the horizontal component is not affected by force of gravity. Don't forget that. So when the ball is moving upwards, that is a vertical motion. Now, when the ball is moving upwards, you have a. Are you still with me? Are you there?
Yes.
Okay. When the ball or whatever projectile is moving upward, you have a vertical motion. Your velocity along will be u sine theta plus gt. Or if the object is just projected, okay, the initial horizontal component of the velocity is what I've given to you before. So, but at any instant, as the projectile is traveling already, not the initial component anymore now, as the projectile is already in motion. So the upward movement, which is the horizontal component, will be u sine theta plus gt. That's acceleration due to gravity times time. So at any instant, that is at a particular time, the horizontal component of velocity is u sine theta plus gt, while the vertical component will be u sine theta minus gt. Why is it minus gt? Because it is against gravity. When the ball is moving upwards, it's against gravity. If the ball is moving downwards, it's in the direction of gravity. That's why it's positive, okay? U sine theta plus gt is when the ball is moving downwards. Please take note of that. U sine theta minus gt is when the projectile is moving upward. Okay, so I think we can start now. I wanted to use some questions because I gave them some questions in the last class, and I hope you know that range is maximum when theta is 45 degrees. Range is maximum when theta is 45 degrees. Okay, you will see all the formulas now, and then we'll start applying them. Range is the horizontal distance. Okay, when I say range now, I just mean the horizontal distance. I want to show you an example of everything I'm saying now. So I'll share my screen with you now. Let me know when you are seeing the screen, please.
I'm not seeing this thing.
Oh, okay, okay. Right.
Yeah, I can see the screen now.
Okay, all right. So let's start. Though we can no longer wait for them. All right. So today I said we will do calculations, and so please take note all the questions that we are solving. UTME past questions. I've worked on them, selected them to just portray so that in a way you are prepared. You are fully ready for each topic that we are touching. So we do not want to take anything for granted. Okay, so I just said projectile. These are some of the formulas that I've mentioned just now. Okay, you have time of flight, which is your capital T. Here, time of flight is 2u sine theta over g. Maximum height, u square sine square theta over 2g. Range, u square sine 2 theta over g. This equation of trajectory is not common actually, so they won't ask you for your level. So range, I told you that range is the horizontal distance. In case you can just write these three formulas down. 2u sine theta over g for time of flight, maximum height u square sine square theta over 2g, then range u square sine 2 theta over g. G is acceleration due to gravity. Okay, then if you look at this, I hope I'm not rushing you. Are you following me?
Yes, I'm following.
Okay, if you look at this diagram, you can have a vertical motion of the ball, you can, or the projectile. I just like using ball, okay? Then the horizontal motion of the projectile. I told you just now that there is no force acting horizontally. There is no force acting horizontally, and so the velocity remains constant, but there is a force acting vertically, which is the force of gravity. So the velocity keeps changing with time. So the horizontal distance is what you call your range. Range. Don't forget that. Range. 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 So I've said that before. So to check your knowledge of even just normal motion, let's check now. Let me check your knowledge of normal motion. Okay, these are some of the things I've said just now. Horizontal component of velocity is u cos theta. Vertical component of velocity is u sine theta. That is the initial, for the initial velocity when the projectile is just beginning its motion. So this is a resolution for initial velocities. So but at any other interval, apart from when it's just beginning its motion, at any other interval is the one I've given you just now. That's When it's moving upward, I gave you. When it's moving downward, I also gave you. So Vy, which is your vertical component of velocity, the Vy will be Vy will be u sine theta minus gt. That is if it is moving upward. If it is moving upward, minus gt. If it is moving downward, which is under the influence of gravity, your vertical component, at any time interval, apart from the initial, the starting point of the journey. If it is moving downward, you are going to have u sine theta plus gt because it's not going against gravity. Okay, so I said I wanted to test your knowledge on normal motion. Now, look at the question here. When you see a question like this where no angle is involved, now just know that you are not dealing with a projectile. So you don't just see a question and you rush to use projectile formulas. You know, in physics, once you use the wrong formula, you have scored 0. So we are going to solve this question together now to take you back to some of the things we have done before. It will give you an advantage. A tennis ball is projected horizontally. That is horizontally, okay? It does not have any angle. That is on the ground now, a straight line, a linear motion. Is projected horizontally. So don't, because they say projected and you start looking for which projectile formula to use, you will be wrong. Horizontally from the top of a vertical cliff 50 meters high with a velocity of 10 meters per second. Find A, the time taken to reach the ground, B, the vertical component of the velocity when the ball hits the ground, C, the distance from the foot of the cliff where the ball hits the ground. So how do we calculate this? If you have done motion, you know that there are particular equations that are very peculiar, that are synonymous to equations of motion. They are usually three. Now I'll write them here now, and we'll see when do you apply them? How do you apply them? So I will just show you equations of motion. So because that question, as long as there is movement, is motion. You have V is equal to, I know you have seen this formula before. I just want to tell you, when do you apply it? What kind of question do you see? How do you know which one to apply in a question? V square is equals to U square plus 2AS. Then you have S is equal to UT plus 1 over 2 AT square. Now, this S, please take note, this S now is distance. You call it distance if it is horizontal, but if it is vertical now, if it is vertical, you call it height, okay? You know a vertical distance is height. So if you say something is high, you are saying the thing is standing vertically. So if you are dealing with a vertical motion, that S, you replace it with H. You replace it with H. Okay. If you are dealing with a vertical motion, that S, you will replace it with H. Are you still with me?
Yes.
Good. But if it is motion on the ground, you call it S. It's still the same thing. Now, I want you to note something again. If it is a vertical motion, all these apply to ground motion, motion on the ground. If it's a vertical motion, you will not deal with linear acceleration. You will not deal with normal acceleration. You are going to deal with acceleration due to gravity. So if an object is traveling, if it is moving upward, if it is moving upward, This formula becomes U, because it's going against gravity, U minus GT. Are you following me?
Yes.
Okay, if it is moving downward, it's going to be U plus GT. That is coming in favor of gravity, U plus GT. Don't forget that. Then this one will become, anywhere you see normal acceleration, now it has to change. And the sign too, you have to watch. So when you're dealing with vertical motion, you have to watch. Is it upward or downward? Is the motion going upward vertically or is coming down? It will tell you the sign to use, whether you are to use plus or minus. If you keep using plus everywhere where you're supposed to put minus, your answer will be wrong. So you have to check the motion. First of all, is this motion on the ground or a vertical motion? If it's a vertical motion, is it going upward or downward? Are you following me?
Yes.
So I can say this formula now, I can write it as U square plus 2GS, right? If it is a vertical motion, is that not so? Or 2GH, because I have said vertical distance, we call it height, 2GH. I can also say is U square minus 2GH if the motion is against gravity. But if the motion favors gravity, it is U squared plus 2GH. Do you understand that?
Yes.
The same thing applies to the rest, okay? As long as it's vertical motion, your gravity, your acceleration will be acceleration due to gravity. And you have to know whether the motion is upward or downward. That one will determine the sign, whether it is plus or minus that you put there. That has been said. So let's come back to our question now. This is the question that we are given just now. I don't know if you want to write it down. You want to write it down?
Okay. Yes.
Write it down so that we can solve it together.
Okay.
A tennis ball is projected horizontally from the top of a vertical cliff 50 meters high. They have given you height now. Height with a velocity, that is the initial velocity, because they are projecting the ball with this velocity. So they are giving you u. They are giving you height and they are giving you u. U is 10 meters per second square. So it's the values there that you need. You don't need to write the whole statement. 50 meters is h, since they say 50 meters high. Velocity of 10 meters per second is u. So you can write h is equals to 50 meters, u is equals to 10 meters per second. Then the questions find a t, time taken to reach the ground. That is t. You can just write time. B, vertical component of the velocity when the ball hits the ground. C, distance from the foot of the cliff where the ball hits the ground. So distance is horizontal, height is vertical. They have already given you the vertical height. They are asking for, the last question is asking for the horizontal distance. Horizontal distance. Are you still with me?
I'm done. Mm.
Okay, so which one can you answer? Of those questions you have written, which one can you answer? Is there anyone?
The time taken.
Okay, or make your attempt. Tell me what you have.
Okay.
You have just 30 seconds. 30 seconds.
The T is 3 seconds.
3 seconds, approximately, right?
Yes.
Okay, so explain, how did you solve it? Can you
The
explain?
last formula there. Mm, the last
Okay,
formula. The one with
okay,
x equals to ut plus
okay.
1 over 280. 80 square.
80 square, okay. Uh-huh.
So we said we can change the s to height, that
Yes,
is h. So
yes.
h equals to ut plus 1 over 2 gt square. And h
Okay,
is given, we have 50 meter.
okay.
We have 50 meter for the h.
H, okay.
The time taken is we are looking for the time taken.
Hmm. What of you? You have not said anything about you. Did
Uh,
you use you in that your solution? If you do not, why? What's your value for you?
u is 0.
Why?
The ball is vertical.
Okay, very good. Very good. Initial vertical velocity is 0.
Is 0.
Okay, okay, okay. So if you
So
look at the okay, continue.
okay, I should continue. So the
Yes.
u is 0 and the t. So if we said u when is together, that is u times t. H equals to
Okay.
ut. So u times
Hmm.
t is 0 plus 1 over 280. Our A, we
80
can
square.
use gravity. Yes, 80
Yes.
square. A is gravity. Gravity is always 10.
10, yes.
So 10 times t square.
Okay. I continue, finish it.
Okay, if we continue, so 1 over 2 times 10, that is 10 over 2. If we divide that, we have 5. 5 times
Hmm.
t square, 5t square. Then we divide both sides by 5.
Okay.
5, 5 and 50 divided by 5, we have 10. So t
Okay.
square, we have t square equals to
Equal
10.
to 10. Hmm.
Then we square root it.
Okay.
We square root both sides, then t
That is
is
what
equals
gives
to
you 3 point something.
3 point some and 1 6 something. Then
Oh,
approximately we have 3 seconds.
good, good. All right. That's correct. Okay. All right. The second question says we should calculate what?
The vertical component of the velocity when the ball hit the ground.
Okay, the vertical component of the velocity when the ball. Where is my PowerPoint? So I said something about vertical component just now. The vertical component, the initial vertical component is still going to be 0. Now, if the initial vertical component is going to be 0, so it means your u is still going to be 0. U is going to be 0. So from those three equations that I wrote, you will discover that since the question is asking us to calculate where are those equations, the question is asking us to calculate for velocity. So, and we already have time. We have acceleration due to gravity, and the motion is favored by gravity because you release something from the top and it's coming down. So, which means it's coming under the influence of gravity. So, plus will be there. So, which of these formulas do you think will be applicable?
The second one, the v
Okay.
square equals to
Yes, you are right. The second one will be applicable. So v square is v is what they're asking us to calculate. V square is equals to u square plus 2gs 2 gh, and we already have h. So v square is equal to 0 square plus 2 times 10 times, what's the height? 50, right? So you have v square is equal to 2 times 10 times 50. That should be 2 times 10 is 20 times 50 is 1000. So v is equal to the square root of 1000. So square root, please press your calculator there. Square root of 1000, what would you have? Hello, can you hear me? Square root of 1000, what would you have?
that is 31.6.
Okay, 31.6. What's the unit of velocity?
Sir?
What's the unit of velocity?
Okay, the unit of velocity, meter per
Hmm.
seconds.
Okay, correct. Then The third question is asking us to calculate, that's the last question, the distance from the foot of the cliff where the ball hits the ground. That is the horizontal distance. So that is where we will apply the third equation of motion. Since it's still under the influence of gravity, so your sign remains plus. So here now you use normal acceleration, linear acceleration. Why? Because they are talking of ground distance. Okay, the distance from the foot of the cliff to where the ball, whatever, hits the ground. So you are dealing with the ground now, and it's horizontal on the ground, so you don't need gravity anymore. So you use normal acceleration. So, and I said something before when I was introducing this thing. I said that the horizontal motion is not affected by gravity. Like the velocity remains constant, and whenever velocity remains constant, it means there is no acceleration. Do you know that?
Yes.
In motion, whenever there is no change in velocity, it means acceleration is equal to zero. All right. Don't forget that,
Okay.
please. When there is no change in velocity, acceleration is equal to zero. So my s now is equal to u 10. That's the initial velocity that was given. The ball was projected horizontally with this velocity. So that's the horizontal velocity times time. The time you calculated was, you said 3.1 something, Abby.
3.16.
Okay. Uh, Plus, I just said that there will be no acceleration because there is no change in velocity. So times 0 times time square. That's times 3.16 square. So if you look at that now, you are going to have your S is equal to 31.6 plus 0 is already here. So everything there is going to be 0. So your answer will be 31.6. So the distance is 31.6 meters. Do you understand this?
Yes.
Okay, so that is just to take you back to some of the things we have done. So let's now come to our main projectile work. A projectile is fired horizontally from the top of a 40 meters high cliff with a speed of 30 meters per second. If you look at this question now, you know it's similar to the one we just solved. Am I right?
Yes.
This one, in this particular one, they are just asking for the time it takes to hit the ground. It's very simple. You already know how to answer the question. So we will not do anything there. Let's now look at another one. A ball is projected at an angle of 30 degrees to the horizontal with a speed of 20 meters per second. Calculate the maximum height attained. A ball is projected at 30 degrees. You are given theta already now. They have given you theta. Then you have been given u. That is the speed. Calculate the maximum height. So which formula are you going to use for this? You know, I showed you a group of formulas for projectile and I asked you to write them down. So if you look at those formulas now, which one do you think we are going to use?
Maximum height.
Okay. Can you use it
The
to
u square sine. Okay.
use it and solve it for me? Let me see. You can write the question down and solve. You have 30 seconds. 30 seconds. Maximum height is very simple. So what's your answer? Just write the formula, put in the values. That is all. What's your answer? Are you true?
No.
It's taking you too long. What happened?
I'm getting 5.
5.
Mm.
Okay, is correct. What if they had asked you for the vertical component of the velocity? Like if the question says you should calculate the velocity vertically, let me use it that way. What would you have done?
The U will be 0, right?
Vertical component.
Okay, the vertical component.
Hmm. That is the initial velocity resolving the vertical component.
Okay, the U sine theta.
Okay, what would have been your answer?
Which is U sine theta.
U sine theta. If you use that formula, what would be your answer?
I use U sine theta. Then I'll get
20 sine 30, right? 20 sine 30 will give you what? 20 sine 30 will give you what?
what is it?
20 sine 30. You've not told me the answer now.
I said 10. 10.
Okay, okay, I did not hear. All right, 10. Oh, what I will do now is let me just sub it here for the sake of others who would have to watch the video later. Solution. So we have to calculate maximum height. So what's the formula for maximum height?
U square sine theta square. Sine square
U,
theta over 2
U,
G.
U square sine square theta Everything over 2g. Correct. So what's the u square? If you look at the question now, what's the u square?
That
What's
is
u
20
rather?
square.
U is 20, so u square will be 20
20.
square, right?
Yes.
Okay. So that means maximum height is equal to 20 square sine, let me put it in brackets, sine, what's the theta in the question? 30, right?
That
Sine 30 square, everything divided by 2g. 2g will be 2 times 10. Acceleration due to gravity is g, that's 10. So I will have my height is equal to 20 square is 400. 0.5 sine 30 is 0.5, so times 0.5 square, everything divided by 20. 2 times 10 is 20, so maximum height is equal to 400 times 0.25, because 0.5 square is the same as 0.25. Am I right?
yes,
Okay, divided by 20. So 400 times 0.25 will give you what? 400 times 0.25 will give you what?
100.
That is 100 divided by 20. So maximum height will be 5 meters. So very simple. That's the answer to that question. So I want you to attempt this one. Let me see. A stone is thrown horizontally with a speed of 15 meters per second from a height of 20 meters. Find the horizontal range. You can see these are different questions, but everything looks like that first one that we solved. Find the horizontal range before hitting the ground. Horizontal range, that is horizontal distance. You have to find the horizontal range before hitting the ground. That is the horizontal distance traveled by this stone. Can you do that?
So the formula I'll be using is range.
I just explained to you now that they are asking for horizontal distance. That range is the same as horizontal distance. But and in this question, if you look carefully now, there is no angle, so you can't use that formula for range that says u square sine 2 theta over g. No, you can't use that one. Do you understand what I'm saying? You can't use this formula for range here. U square sine 2 theta over g. No, because you are not given an angle. So it's not every time that when they say an object is thrown or projected that you just quickly pick that formula. So you have to look at, is this object thrown at a particular angle? If there is no angle given, you have to treat it as normal motion. Is that okay?
Oh,
Do you understand what I've just said?
yes.
Okay, so make your attempt now. A stone is thrown horizontally with a speed of 15 meters per second from a height of 20 meters. They are giving you height, they are giving you speed. Find the horizontal range before hitting the ground. That is the horizontal distance. Range is the same thing as horizontal distance. That is distance on the ground. I hope you know that without time, you can answer the question. You know, if you look at the first question we solved, if you go back to the first question, you discover that they first of all asked us to calculate time taking to reach the ground. If there is no time, you can't answer the third question. So the question they're asking you now is similar to this third question, the distance from the foot of the cliff. The question they're asking you now is similar to this third question, but you need to solve for time first. Are you with me?
Yes.
Okay. So solve for time
Good
first.
evening, sir.
Good
Good
evening,
evening.
ma.
Sorry,
Good
excuse
evening.
me.
How are you?
I'm fine. Is it continuation of last week topic?
Your line is breaking. I can't hear you clearly.
Okay, I said which topic are we treating?
Okay, okay. You are welcome. Were you asking a question?
Yes, sir. Can you hear me?
Okay. Yes, I can hear you now.
Okay, I was asking which topic are we treating tonight?
Okay. Today we want to trouble ourselves with calculation questions under projectile, and if time permits us, we'll move to impulse and momentum.
Okay, sir. Thank you.
Although we have solved some questions before you came on, we have been here since 6:30.
Uh-uh. I thought the class is 7:30.
Dima did not. Okay, please be informed. It may no longer be 7:30. Okay, due to just slight changes on my, should I say slight, but with time it's just for a while. We'll go back to our 7:30. Okay, I thought you were informed.
No, 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 no. I
Okay,
wasn't.
but don't worry, the video will be available too. Okay, just move on, just move with us from here. Where you meet us now, just continue from there. You understand what we are doing. Is that okay?
It's okay.
All right, the video is still there for you to watch again, so you'll be fine. So I want to solve this question that is on the screen now. A stone is thrown horizontally with a speed of 15 meters per second from a height of 20 meters. Find the horizontal range before hitting the ground. Now, if you look at this question, it will look like a projectile question, but you are not given an angle in this question. So you can't use projectile formula. That they ask for range now does not mean you just come quickly to R is equals to U square sine 2 theta over G. The question does not give you theta, so you can't use this formula. So what am I going to do then? Are you following me? I hope you are following me, right?
Yes.
Yes, sir. Sorry, I
Good.
can't
So
hear
what I'm
you.
going to do is, you can't hear me. Me, I can hear you. Please, who else is not hearing me? Is it everybody that is not hearing me?
No.
So, somebody is hearing me. Oh. Are you sure it's not your network? Hello, are you hearing me now?
Yes, sir, I can hear you now.
Okay, so I was saying that since you were not given angle in this question, so you can use the formula for range that says R is equals to U square sine 2 theta over G. You can't use that because there is no theta in this question. There is no theta. So what am I going to do? So this is what I will do. You will use the normal equation for motion. It's just there's a little explanation I made while starting this class that for a question like this, horizontal range is the same thing as distance on the ground, like normal distance, motion on the ground. Okay, that's what they are asking for. So that is distance. They are actually asking for distance now. from that explanation. They are asking for distance on the ground. Okay, now if I want to, last time we talked about equations of motion where you can have h is equals to ut plus or minus 1 over 2at squared. Why did I say plus or minus? Do you still remember? I say plus or minus because since it's a vertical motion we are dealing with, the question says something is thrown. Something is thrown. Let's go back to the question. A stone is thrown horizontally. You know the stone will be coming down. So this stone is under the influence of gravity. So if it's coming down, the sign will be plus. But if the motion is a vertical motion that is upward, the sign will be negative. So this one now, the sign will be positive, of course, because the stone will be falling downwards. The stone will be falling downwards. So I'm going back to my formula here now, and I'm going to make this sign, I'm going to make it positive now. So this is the question they are asking me to, uh, let me use, so let's go there. This one is height, don't forget. Now, why do I need this formula? I want to find time. So time, why do I need time? Because the main formula that I'm going to use is this one. S is equals to ut, because motion on the ground does not have acceleration due to gravity. So the normal formula I'm supposed to use is this, but I'm not given time in the question. So I have to use this first formula to find the time. So in finding time, I was given height. They said the height is 20 meters. The height is 20 meters. The height is 20 meters. So I will do 20. So that is 20 is equal to ut. Initial vertical velocity is 0. Please don't forget, since they mentioned in the question that the stone is thrown horizontally. So please note this technical stuff. When an object is thrown horizontally, it means the initial vertical velocity is going to be 0, because they have just said the object is thrown horizontally. So initial vertical velocity is going to be 0. So my u is 0 times t. There is no time. Time was not given in the question. It's the one I need this time so that I can actually solve the question. That's why I'm using this first formula. You need time. And this is the only formula that will give you the time. So 1 over 2 times acceleration due to gravity is 10 times time square. We don't have time. Time square. So 20 is equals to 0 times t is 0. It's equal to 0 plus 1 over 2 times 10 times t squared. 1 over 2 is 0.5, right? 0.5 times 10 will give you 5. That is half. Half times 10 will give you half. We give you 5. Half of 10 will give you 5. So which means 20 is equal to 5t squared. 5t squared. So you divide both sides by 5. When you divide both sides by 5, t squared is equal to 20 over 5. 20 over 5. So it means t squared is equal to 4. So you take the square root of both sides. When you take the square root of both sides, you will discover that your time t is equal to 2. Okay, let me write square root of 4, because square root of 4 is equal to 2. So now I can use this time that I've just gotten to answer the question. 2 seconds to answer the question. So Let me get back to the question now. Since they're asking me to find distance on the ground, horizontal distance. So this is the formula I'm going to use because this is the formula for horizontal distance, linear motion. So ut, you are given the initial velocity when the object was thrown horizontally. They said the speed was 15 meters per second. So my u is 15. So what I want you to note in these two things that I've solved now, or that I'm solving, I've solved the first one. Why did I use zero in this first one? Please let me know whether you are hearing me because you have to understand these things. It's the reason why students normally get physics calculation wrong, especially in motion now. Can you all hear me?
Yes.
Okay. You can hear me, right? Apart from Shakiruddin, hope others can hear me. Hello, are they still there? Or they have slept off?
Yes, sir, we are hearing you.
Okay, okay. That should be Adamu, right?
Yes.
All right. So I said, why did I use zero in the first one? And I'm using the speed that is given in the question to solve the question. The speed was given to be 15. Now I want to use that 15. But if you look at the first one, I did not use the 15. The reason is this. The question said the stone is thrown horizontally. But this formula that I used, this first formula now, is for vertical motion. So which means there is no initial vertical velocity since I'm using a formula for vertical motion. Whereas the speed that was given in the question is for horizontal motion. So the vertical speed will be zero. The vertical speed will be zero. Okay, that's why I did not use the 15 there. The vertical speed will be zero because the stone was thrown horizontally. All right, so let me continue now. That is 15 times. You can see now I have to use that time, the time that I just calculated. 15 times 2, then plus 1 over 2. Now, another thing I want you to note, please, these things that I'm saying, if you have to write them down to remember, please write them down. My acceleration, my linear acceleration here is going to be 0. Why will it be 0? Why? Because in this case now, there's no change in velocity in a horizontal motion, please, especially when an object is thrown, a projectile is thrown. There is no change in velocity. And if there is no change in velocity, acceleration is going to be 0. Now, acceleration is going to be 0 because there is no change in velocity. Why is there no change in velocity? Is because it's not under the influence of gravity. Change in velocity will occur if the projectile is under the influence of gravity. So since this is a horizontal range, distance on the ground is not under the influence of gravity. So there will be no acceleration. Acceleration will be 0 because there is no change in velocity. Velocity remains constant. That's what I'm saying. And when velocity remains constant in motion, acceleration will be 0. So time is still 2 square. So everything at that side will be 0 apart from this 15 times 2 will give us 30 plus everything here. Now after the plus, everything is going to be 0 because anything you multiply by 0 will give you 0. So my answer now is that the horizontal range they are asking me to calculate, which is S. Once you see range in a question, I've said it before you guys came online. Range means distance, please. Horizontal distance, distance on the ground. Don't forget. Range means distance on the ground. That is why I am using S is equals to UT plus 1 over 2 AT square. So, but if it is a vertical motion, you will not use A. You will use acceleration due to gravity. Acceleration due to gravity. Please don't forget that. Who has a question there? Nobody, right? Nobody. You know, last class, the projectile questions that I gave you people, they were just straightforward. That if I calculate maximum height, or you just say u square sine square theta over 2g. Calculate time of flight, you just say 2u sine theta over g. Now, but these ones, you can have questions that are not straightforward. That is why I brought these questions. Okay, you can have questions like this that are not straightforward. How do you calculate them? Very important. That's why I'm doing this. Do you understand what I've just done?
Yes, sir.
Okay. Okay, let me give you one question to solve now. Let me give you this one is a past question. Let me remove the answer from there so that you can solve. Let me enlarge it so that you can see. A projectile is launched at a speed of 40 meters per second at an angle. You can see in this one now, you are given an angle. So it will be easier for you to solve. You just go and pick the formula for time of flight. You just pick the formula for time of flight and then use it to solve. Well, in a case where you are not given the angle, is then that you will do what I've just done here. So this in this question now, if you look at it, you are not given any angle, you are given speed and height. But yet they say it is a stone that is thrown horizontally. That is still projectile, but you are not dealing with an angle. You have to do something like this. For this one, you are given the angle to the horizontal, so it is easier for you to solve. Please solve it quickly and tell me your answer. You have 1 minute, 1 minute. 1 minute is even much. Just take the formula for time of flight. Time of flight, just take the formula. That is all. Your speed is u. U is 40. Theta is 45. U is 40. Theta is 45. Quickly, quickly. We don't have time. This class we have to end by 8. Who has finished solving, or I should solve it? Hello, are we through? Okay. So if you look at the question, U is given to be, and then theta was also given. Theta was given to be 45 degrees. And then U, the velocity was given to be 40 meters per second. 40 meters per second. So, and you have to calculate range. The question says you should calculate time of flight, rather, sorry. So I should have added the range to that question and even maximum height. But time of flight is equals to what? Who can tell me the formula for time of flight? We did this in the
2
last
u
class.
sine theta over g.
Okay, 2u sine theta over g. What if the question asks for formula to reach maximum height? Formula to reach maximum height. If the question asks for time to reach maximum height, rather, time. What's the difference between time to reach maximum height and time of flight. What's the difference between them?
That's use sine theta over g.
Yeah, that is time to reach maximum height. Yes. So T now is equal to 2 times 40 sine 45 over 10. Everything divided by 10. Acceleration due to gravity is 10 in this case. So sine 45 will give you what?
Zero
Press your
point
calculator.
seven zero seven one.
Okay, that is 80 times 0.7071. Everything divided by 10. So 80 times 0.7071. 80 times 0.7071.
That's 56.57.
Huh?
56.57.
80 times 0.7071. What will
And
you have?
56.568.
Okay, divide it by 10 now. What are you going to have? That's 5.66. So I can say 5.6 seconds. Or if the question asks you to approximate to a whole number, that's for the nearest second. I can say it's 6 seconds. But let me just keep it here. So because you will see in the option, you will know whether you have to approximate it to a whole number or not. Okay, so let me give you one question as an assignment. So the one question now is very simple, okay, and straightforward. So this is the question here. This is the question here. That is A. I'm trying to enlarge it so that you can see it. This is the question. This is the assignment. Write it down quickly and I will send this note to the Telegram group. Please write it down, all right? I'll send the notes to the Telegram group. I believe you also get the videos also. For those that joined us late, uh, please watch the video, go through the notes, look at the solutions, and if you have any question, just drop it in the Telegram group. A football is kicked at 20 meters per second. That is the velocity. 20 meters per second at an angle of 37 degrees to the horizontal. Calculate the horizontal range of the projectile. Very simple question. Very simple question. Okay, so let's stop there for tonight. I believe you have written it down, right? Have we all written it?
Yes.
All right, all right. So any more that I need to pass across to you, I will send it to the Telegram group. Or if you have any question, please feel free to ask me in the Telegram group. I will respond there. So I have to go now. I have to go now. See you in the next class. Please make sure others please come online on time so that we can do a lot together. We have much to do. We have much to do. Is that okay?
Okay, sir.
All right.
Yes, sir.
Have a wonderful night.